Hello all, welcome back to Edison Technology YouTube channel. In this video, we're going to see about title of classification of cervical cancer using deep learning approach. First, I will explain our abstract. Here, the abstract summarizes that cervical cancer remains a major cause of cancer-related fatalities among women worldwide, making early detection critical for improving survival rates. This study focuses on leveraging deep learning technique, specifically CNN, that is convolutional neural network, to classify cervical cancer using clinical and demographic data. While traditional machine learning models such as XGBoost, support vector machine, and random forest has been commonly used for classification tasks, these researchers expose the advanced CNN capturing complex patterns within data. The dataset undergoes pre-processing steps, including feature selection and data normalization to enhance model performance. A comparative analysis is conducted using evolution metrics such as accuracy, precision, recall, and F1 score. The finding indicates CNN-based deep learning models outperform conventional machine learning method, demonstrating their effectiveness in improving classification accuracy. These results underscore the potential of deep learning for earlier and precise cervical cancer detection, facilitating timely medical intervention and improving patient outcomes. Here, our introduction summarizes that this cancer is one of the most common cancer affecting women globally and remains major public health issue, especially in lower and middle income countries where mortality rates are high. According to WHO, It's it is the fourth most prevalent cancer among women. This primary cause of cervical cancer is persistent infection with high risk strains of human, which leads to abnormal cell growth in cervix. Although preventive measures such as HPV vaccination and routine screening programming exist, many women are still diagnosed at an advanced stage due to factors like lack of awareness, limited healthcare access, and economic constant. Beyond its direct impact on affected individuals, cervical cancer has broader social and economical consequences, particularly in developing nations with inadequate healthcare infrastructure. The delayed diagnosis and costly treatment options contribute to increased health disparities. Early detection is essential for improving survival rates and reducing the burden of healthcare systems. Traditional diagnostic methods such as pap smears, HPV test, and colonoscopy are effective but require skilled professionals and specialized equipment. And these multiple hospital visits making them less accessible in remote or underserved area. Here, our problem statement explains that okay, in recent, cervical cancer remains a major global health concern, requiring early accurate detection to improve patient outcomes. Traditional diagnosis methods such as the SPAP and CMS and HPV test are time-consuming, requiring specialized medical expertise and may not accessible in resource-limited settings. These challenges highlight the need for automated and effective diagnostic solution. This study focuses on application of the deep learning, specifically convolutional neural network for cervical cancer. The CNN model will be trained on clinical and demographic data, evaluated using performance metrics such as accuracy, precision, recall, F1 score, and tested on unseen data for validation. The goal of this research is to develop an effective AI-driven approach for early cervical cancer detection, enabling medical intervention and improving healthcare accessibility. Yeah, and this is our objective. And existing with that, this is our devotion method. I'll show you a block diagram so that you have a good understanding about this project. Yeah, first we have our calculated data set and we'll do pre-processing. That is nothing but the normalizing, and then we will do some of the techniques here. And after this, we will do feature extraction by using our CNN code. After this, our After this, our extracted picture should be go to a CNN model. After this, a model will be evaluated using some metrics, and then after our model will be uploaded into our testing code. So this is our testing code. Here we will test the unseen data and which only as a final code. So first I will show you our training data. Here's our training data. Uh, I'll show you our data set once. You can see that once. These are data set. Okay, these are the images. It's type 2 or it's type 3. Okay. So this is our training code. Here's targets nothing but our three types of data on our dataset part. Here we are changing our file name to categorical numbers. That's what we're doing here. And our loaded data will be split into train files and train targets. And the loaded data will be separated into 80% for testing, so 80% for training and 20% for testing. After this, these the images will be transformed into tensor formats. Tensor is nothing but array formats. That's what we are doing with this paragraph, in this function. After this, our tensor format should be in the range of 0 to 255. That's what we are doing here. And then these are these are our parameters for our model. And here's our model we built here. After building a model filtered in here. That's what we're doing here. And then here you can see our graph. That's what will be displayed. And then you can see by using this kind of metrics, our metrics will be filtered. Accuracy, precision, equals bar, equals bar. After this ROC curve will filter. This is one of the metrics, and you can see the convolution matrix, like how much truly it's labeled and how much false is labeled. So you can see here. After this, our model will be saved as trained model underscore DNN 1.h5. Can see this. Yeah, this is our model. We're gonna take this model and then we will put in testing code. We'll dump in testing code. That's what we've done here. Okay, I'll run this testing code. You can see this once. It will take 2 to 1 minute. Just this sort of our first window, GUI. Since it's sensitive data, so we are given certain thing. And I'll select any one of the testing image so that it will predict here. Uh, yes, I consider this patient has no cancer. Now select any other of the image. Things. You can see inside. Okay, if you have any doubt regarding this project, you can leave a comment in comment section and don't forget to like, share, and subscribe. Thank you.